PRIZM's conic graphs feature allows access to graphing of conic sections. Users not only have the ability to graph conic sections, but to solve for a variety of important features of those graphs, such as a directrix, asymptote, or focus. After selecting conic graphs from the main menu, the PRIZM will prompt you to select an equation. Parabolas, circles, ellipses, and hyperbolas are all options from this menu. You'll notice that for the conic sections that are commonly represented with more than one type of equation, you'll find those different equations as options in this menu. A student might encounter a circle with a center of -2, 0 and a radius of 2, either written as the factored equation, the quantity x plus 2 squared plus y squared equals 4, or as the equation x squared plus 4x plus y squared equals 0. Both are options in this menu, but let's select the factored form to take a look at what conic graphing looks like with the PRIZM. Most of the options available with standard graphing, such as trace and zoom, are performed the same way with conic graphs. However, GraphSolve has a set of options specific to the conic section you are working on. In the case of a circle, you'll find that x-intercepts and y-intercepts are still available, but center and radius are additional options. Those GraphSolve options are different for each conic section, so let's continue by looking at each of the others. This parabola has the equation y equals the quantity x plus 2 squared minus 1. There are more features of interest on a parabola than with a circle. Within the GraphSolve menu, you'll now find the option to solve for the parabola's focus, axis of symmetry, directrix, vertex, the length of the focal chord, intercepts, and eccentricity. With the axis of symmetry and directrix, the PRIZM not only finds the equation, but also displays their graphs on the screen. Next up is an ellipse. Of course, with an ellipse, there is more than one vertex and more than one focus. Selecting vertex or focus from the GraphSolve menu will reveal the first vertex or focus. The additional points are accessed using the left and right arrows. Center is once again an option, as is eccentricity. Finally, we have the hyperbola. Within the GraphSolve menu, you'll find similar options to the ellipse, but this time you can have the PRIZM find asymptotes. The asymptotes will be displayed on the screen along with the slope of each of the lines. In addition to rectangular coordinates, PRIZM users have the option to graph conics with polar or parametric equations. Here's an example of an ellipse graphed using polar coordinates. You'll notice that all of the graph solve features that were available in rectangular coordinates are still there. Here's an example of a circle graphed using parametric equations on the PRIZM. The conic graphs feature provides a simple way to graph and analyze the conic sections. Rather than limit students' capabilities while graphing conics, PRIZM offers additional capabilities to solve for the features that are critical to understanding the conic sections.